Hello everyone. So welcome to the channel and let's straight away start with the today's Leetcode problem of the day, which is like maximum square area by removing fences from a field. I am hoping like first you have tried it by yourself and then only you are coming to watch the solution. If you haven't tried, first I would request you first actually let like at least sit to sit for half an hour to give a try for this question, and just first at least understand the problem what it is saying, because it will take little time, and then try to solve by yourself. And if you are not able to get any idea, then you can like again resume it and see the approach. Okay, we will solve here. I was also not able to solve, but yes, now we can see together. Okay, so question is, there is a large m-1 cross n-1 rectangular field with corners 1 1 m n containing some horizontal vertical fences given in the arrays h fences v fences respectively. Horizontal fences are from the coordinates this and this. Okay, let me first make you understand what is the question is. Let's say we will take this example, m equals to 4, n equals to 3 given. Okay, and h fences is given as 2 3, v fences is given as 2. Question is saying large rectangular field. Okay, there is a rectangular field with corners 1:1. Let's say we will consider this as 1 1 1 and mn. This is mn corners. Mn, how mn? What it is, it will be m is 4, means 1 2, okay, 2 3 4, m is 2, n is 3, 1 2 3. So this is one rectangular, this is one rectangle, okay, where corners are 1 1 mn, and we have given horizontal fences, vertical fences. What that means is, horizontal fences means at 2 and 3. What it's saying, horizontal fence at 2 and 3. How we are saying, like how we are saying 2 and 3, because it is given here, see here. Okay, if we see here, horizontal fence is I 2 1 2 I 2 n, means if we have given 2 3, let's say 2 3, okay, h fence 2 3, so I means let's say 2, and then 1 2 h fence I, which is 2 to n, other one is 3 to 1 to 3 to n is we having 3. Okay, so what it's saying, one horizontal fence is 2 1 2 1 2 2 2 to 2 3. This is meant by this one. One horizontal fence is 3 1 means this coordinate, 3 2 means this coordinate, and 3 3 means this coordinate. So these are two horizontal fences. Same way we have vertical fence at 2. What that means is, vertical fence are from the coordinates 1 2 I. So I we have 2 only. So 1 2 2 m, this one, okay, m 2 I means 2, v fences of I means 2. So 1 2 to this one, so 1 2, then 2 2, then 3 2, m we having 4 means we'll go to 4 2. So what that means is, we have this vertical fence 2 1 2 2 2 3 2 4. This is one vertical fence we are having. Okay, so basically two horizontal fences we are having. one vertical fence we are having like this. So this is how our example shown. Now question is, return the maximum area of a square field that can be formed by removing some fences. So what it is saying, we can remove some fences to make a square, and we have to return the maximum square. So what is the maximum square we can make by removing some fences, and we have to return the area. So what is the area of a square? Area of a square is side square. Okay, so basically our question is to find the side, the maximum. So if we get the maximum side, means our area will be maximum only. So we have to find the side of square. We have to make a square, and then the side of the square we have to return the maximum area. Okay, if it's impossible to make a square field, we have to return -1. Okay, then one is since the answer may be large, return it modulo. Okay, the field is surrounded by two horizontal fences from the coordinate 1 1 1 n 1 1 to 1 n. Okay, this 1 1 to 1 n means this one, same way, and m1 to n. Okay, so what it is saying, this note is saying is, we have two horizontal, which is this one, to make a square, to make a field. These two horizontals are by default. Okay, and these two verticals are by default. Okay, apart from these fences. Okay, so this is our field. Now we have to make a, how we can make a, like how to get this maximum square. So if we see this example, what is the maximum square is, okay, so let's say this, wait, 3 and 4, and we have these two fences, this fence, this fence, this fence. How we can make the maximum square? Okay, if we remove this fence and if we remove this fence, okay, we have removed. So now we have this, which is two side, length is 2, 1 unit, 2 unit. Here also length is 1 unit, 2 unit. So 2 cross 2 is equals to 4. This is the output. Okay, wait, sorry, this is our output is 4. Removing the horizontal fence at 2, vertical fence at 2 will give a square field of area 4. Okay, means we have now this one is our square, okay, area. So we have to find this. How we can approach? Same way, other example also. Let we see the other example. Here it's saying m equals to 6, n equals to 7, 1 2 6 7, 1 2 3 4 5 6 7. H fence is 2. Okay, this is one H fence. Vertical fence at 4. Okay, this one vertical fence at 4. Can we? No, we can't. If we remove this one, what, we will not be able to make. And if we remove both also, we can't be able to make any square. That's why we are returning -1. Do we have some constraints? Yes, we have some constraint, but that is normal only. m n value will be ranging from 3 to 10 to power 9. H fences, V fences length also, it's not more than 600, less than n, m less than n. H fences and V fences are unique. What that means is, let's say we have one fence here and one fence here. So how we will represent two H fences? 2 3, right? These two. We can't have 2 2. What that means is nothing. We have 2 and then 2. So that's why it is saying we have unique. Yes, so we have unique. Okay, I hope you understood the question. Now let's go to the approach. So if you got little bit of idea what a square is having both sides equal. Okay, And how we can get this both sides? Okay, let me make you understand through one example. Okay, let me take this example. 1 2 3 4, will not take much many. Wait, sorry, we'll take small case only so that you will be able to understand better. 5 1 2 3 and 4. So this is n equals to 4, m equals to 5. Now let's say we have horizontal fence at 2, at 4. Also we have horizontal, or we have verticals at 1, we have verticals at, this numbering we have done wrong, is it? Okay, sorry, this is 1 2 3 4 and 5, n equals to 5, and we have these two. Cool. Okay, let we not take this one, and we will take this one. So we will be having one more question. Now how we can find square here? If you observe it properly, okay, this is one horizontal line. So what is this side length between these two? What is the side length? Is 1. Okay, and we have vertical line here also. So what is the length here? Is 1. So our square side will be 1 here. So this area will be 1. If we get any of such things, we will be having 1, same only. Okay, so okay, now okay, wait, yes, yeah. So now let we understand, let we first find what are the possible sides we can get from horizontal fencing. Okay, let's say this is one side, this is one horizontal fencing, this is one horizontal fencing. What is the side giving? This horizontal fence side giving is 1, and this line is side giving is 1 2 and 3. These two sides are possible with these two fencing. But if you see, if you take this line also, this as a horizontal fencing also, it will give 1 side, 2 side, 3 side, 4, means 4 unit, means 4 side of a square can be a 4 also with the horizontal fencing. Same way in vertical fences. Okay, vertical fences, if we consider this vertical line, this will give a side of 1 size. There is no vertical line. If we consider this vertical line, this give a 1 2 3 units side, means 3 length. If we consider this as a like vertical fence, it will give 1 2 3 4 length. So see, if this with this vertical line we are having 4 length, 1 2 3 4. How we will calculate these lengths? So there is a simple idea. Okay, first is in our horizontal fence. What is the horizontal fence here? 2, this one, and 4. Okay, first we will add our this as a horizontal also, this in our horizontal fence also. If you see carefully, these are also horizontal fence. So we can get 1 here. Okay, 2 4, and this is our m, means 5. So these are our horizontal ones. Same way in vertical fence also we are having just 2 4. So we can add 1, this one, and 2 4 same, and this n equals to 5. So we are having vertical fence also, horizontal fence also, by including these side border ones. Okay, now if you have to get the sides, what are the possible sides length provided by horizontal fences? If you if you do the subtraction between 2 minus 1 will be 1, one length possible, right? If 3 is not, we are not having any fence here, we have fence at 4 minus 2 will be having 2 length, which is this one. Okay, so 2 unit length, so we can have 4 minus 2 is 2. Also we can have 5, this we have this 5 one, right? 5 horizontal minus 1 will be having 1 2 3 4 units. Also 5 minus 4 will be 1, 5 minus 2 will be 1 2 3 units also possible. So basically what we are doing is we are finding every possible side length with horizontal fencing. Okay, how we can get it is very simple. This is like very simple. What we can do is we will iterate over this and we get all possible things. How we can get all possible things? 1 2 4 5. We can keep an index I here, j here, j minus I. Okay, j means h fence of j minus h fence of I will be our 1. 2 minus 1 1, then j will be here, 4 minus 1 3, j will be here, then 5 minus 1 4. These 3 lengths possible. Then we will increase our I here, and again we will repeat j from here. 4 minus 2 2. Okay, 4 minus 2 2 length possible. So these things we will get in a set, we'll put in a set, so that we can get just unique values, unique lengths. Same way we will do with vertical fence also. Okay, so here we are having 1 2 3 4. These lengths are possible. How? If you see, one length possible by between these two. Okay, 2 lengths possible between these two, 2 length possible, 5 length, 3 length, this and this is 3 length possible, this one, 4 length possible is between these two. Okay, same way if we consider this one also, if we get the same 2 minus 1 every possible side length possible, we will be having for this one also 1 2 3 4. And when we check what are the common lengths, so one is there, this one is there, these are the intersections, right? So means one side possible here also, one length side possible here also, means one horizontal possible, one vertical possible with same side length 1 1, means this is a square, this can be a square. So we can consider a maximum side variable which will consider the side. So now we get one side of length 1, we get 2, so 2 here also, so our maximum will update to 2. We got the size with 2. So means what it is representing is where it is, yeah, this one, it is representing this square. This one also 2 length and this one is 2 length, means this square it is representing 2. So 2, 3 also, 3 is common, so we have 3 side also, where it is, if we see this one, 4 minus 1 4 minus 1 means this one also 3 length, 3 unit means 3 cross 3 is a square of 3 side. Okay, do we have any 4 also? Yes, 4 is common, means 4 side also possible for both. The horizontal giving 4 as this one, vertical giving 4 as this length, so means this is one square, complete square is possible. So our maximum side will be 4. Okay, our maximum side will be 4. Then we can return our max side into max side, means 4 square will be 8. It will be our maximum area from this rectangular field. Now if you got the idea, so what we have done is, first we have added these two, okay, to our edge fencing. We included this line. For vertical fences also we included this line also as our vertical fence. Then we are checking all possible values in both, inserting into sets. We do not have to insert in this also to check the common. We will simply just get the maximum value and we will check in this. If it's possible, okay, we will consider that. So that we will not be having to store one another set. Okay, so if you got the idea, we can maybe simply code it. I already have the solution here, which I will let you go through it, and now you will be able to understand properly. Okay, so this is just a step by step what we have done. First we pushed h fence with these upper lines, upper boundaries as h fence. Then for vertical we kept the border, these two lines. This is our rectangular field, right? So we have kept these two. Now we are sorting. Why we are sorting? When we pushed here, so our order can be, let's say we got 2 3 as h fans. When we pushed, 1 will be here, m will be here. Then when we will be getting the differences, we will get the negative or something. So we don't have to go through this. We just sort to get the proper ordering. We will sort both h fence and v fences. Then we collect the horizontal gaps. So we will calculate what we will calculate. Let's say this is our square feet, these are horizontal lines. We will calculate these side lengths, how many combinations are possible. Okay, so simply what we will do, we will take a set, we will iterate from 0 to this, then j is equal to I plus 1 to this, and in our set we will insert h fences of j minus h fences of I. Okay, so our set will be considering all possible side lengths from with respect to horizontal fencing. Same way we will take a maximum side as -1. Same way we will calculate for vertical fences. What are the possible side lengths possible from vertical fencing? And what we will do, we will get the vertical fence length. Then we will, instead of creating another set, we will just look for that value in our horizontal set, h gap. In this set, in h gap, this is our h gap. In this set only we will look if it's there. Okay, if it's there means both are, that side length is common in both, means the side length is same, two sides are same, means it is a square, it is making a square. So what we will do, we will store the maximum side. So -1, we will store the maximum side every time. Okay, after this loop, now we will check if our max side equals to -1 only, means we did not got any side which is max, like more than this one, means we did not got any square possible. So we will return -1 simply. If we got any sides, then we will take the square of the side, we will do the modulo, so that result should not go to out of bound, and we will convert to long, because we have this constraint as, right, we have this constraint 10 to power minus. So let's say m or n both are 10 to power 9 only, then 10 to power 9 into 10 to power 9, it will go out of bound with integer. So we will take long as answer, and we will do modulo which they have asked, and we will return the maximum side. This is not, don't this is maximum, just a variable mistake only from my side. We can store it in some result. I just stored in max side only, so return max side. Okay, yes, so this is the solution of today's problem of the day on Leetcode. If you have any doubt, you can comment, and if you have any suggestion on improvement for the way of explaining, okay, you should comment, because this is my first video and I hope you like the solution. But I would just say first you should try by yourself and then only get to solution. Thanks.